Understanding geoengineering projects and their purpose. Geoengineering refers to large-scale interventions in the Earth's natural systems aimed at counteracting climate change. These projects often involve manipulating the atmosphere, oceans, or land to reduce global warming or reverse environmental damage. The idea is to complement traditional climate change mitigation efforts, such as reducing greenhouse gas emissions, by directly altering the Earth's climate. Types of geoengineering projects. Geoengineering can be divided into two main categories: solar radiation management, (SRM), and carbon dioxide removal, (CDR). SRM focuses on reflecting sunlight away from Earth to cool the planet, while CDR aims to remove carbon dioxide from the atmosphere and store it. Each category includes various techniques, such as aerosol injection, afforestation, or direct air capture of CO2. Solar radiation management, (SRM), techniques. Solar radiation management involves methods that reflect sunlight back into space to cool the Earth. One proposal is to inject aerosols or reflective particles into the stratosphere, mimicking the cooling effect of volcanic eruptions. Other methods include creating reflective clouds or installing mirrors in space. While these techniques could temporarily lower temperatures, they do not address the root cause of climate change, carbon emissions. Carbon dioxide removal, (CDR), strategies. Carbon dioxide removal strategies focus on directly removing CO2 from the atmosphere. Techniques like direct air capture, ocean fertilization, and afforestation are some of the most studied methods. By increasing natural processes or using technology to capture CO2, these projects aim to reduce the greenhouse gases responsible for global warming. CDR offers the potential for long-term climate stabilization if deployed at scale. Potential benefits of geoengineering projects. Geoengineering offers several potential benefits, especially if conventional climate solutions fail to achieve desired outcomes. These projects could help limit global temperature rise, prevent catastrophic climate impacts, and protect vulnerable ecosystems. In theory, geoengineering could buy time to implement more sustainable solutions or reverse the worst effects of climate change. Environmental risks and unintended consequences. Despite their potential benefits, geoengineering projects come with significant environmental risks. For example, solar radiation management might alter weather patterns, causing droughts or disrupting rainfall, which could have severe consequences for agriculture and water supply. Similarly, carbon dioxide removal techniques could have unintended side effects, such as ocean acidification from large-scale ocean fertilization. Ethical concerns surrounding geoengineering. Geoengineering also raises ethical concerns, as it involves altering the planet's climate systems on a large scale. Questions about governance, accountability, and fairness arise, especially in terms of who controls such projects and how they are implemented. There is also concern over the impact on vulnerable populations, who may experience the negative effects of geoengineering interventions. Geoengineering as a temporary fix or long-term solution. While geoengineering may help mitigate climate change in the short term, it is not a comprehensive solution to the climate crisis. Most experts agree that geoengineering should only be considered as a temporary or complementary measure alongside efforts to reduce emissions and transition to renewable energy. Over-reliance on geoengineering could delay necessary actions to address the root causes of climate change. The need for research and regulation. Due to the potential risks and uncertainties, many scientists argue that geoengineering should not be deployed without further research and international regulation. Governments and organizations are working on establishing frameworks for research, testing, and governance to ensure that geoengineering projects are safe, effective, and equitable before any large-scale implementation. The future of geoengineering in combating climate change. Geoengineering remains a controversial and evolving field, with ongoing debates about its viability and ethical implications. While it may offer some solutions to climate change, it is clear that geoengineering is not a silver bullet. Comprehensive, global efforts to reduce emissions and transition to sustainable practices will remain essential in the fight against climate change.